All right, we're being sent in off the bench to come in here and solve example 2B. Let's go get it, all right? So you'll notice that we did the rewrite on this particular one. We changed the radical into a fractional exponent. Now, there is multiplication here, but as you recall, there is not a multiplication rule for integration. So this would hopefully be the tip-off to us that this is not terms with powers like the previous examples, so we need to do substitution. And the other thing to notice here would be that this would be a definite integral, wouldn't it? Because it's got limits of integration. So, my hope would be that you would look at this and say, you know what, that quantity being raised to a power, would be a good candidate for setting equal to u, and therefore the variable u will take the place of that entire quantity, won't it? And so again, we're going to jump over here and replace that with a new integral. We're going to leave our x because they're too complicated. We're like, goodbye x, you're too complicated for me. And we're going to run off with u. Alrighty, so this portion of the original integral becomes u to the 1/2 power. And as mentioned earlier, every single expression in the entire integral needs to be substituted. So therefore we have that part of it. Always, always, we then build a dx from that original relationship, from that original substitution. So if we differentiate this with respect to x, do we have an injury? I'm going to hang in there. We'll be all right. Okay, so that will equal 2x. I'm playing hurt. Okay. But then, if we clear the fraction, you'll notice that we've got a du here, and it equals 2x dx. And the beauty of this would be that not only did the dx fall in our lap, but look at that! We also got a 2x here. Now look, it's pretty similar to the original integral. The only difference is that's a 1x instead of a 2x. So as we've seen multiple times, if something falls in our lap, all we have to do is change that 2x into a 1x, and in this example, wouldn't multiplication by 1/2 on both sides give us that? So this will give us 1/2 du equals x dx, and you will note, that the x and the dx in the original integral can be replaced with 1/2 times du. So I like to put that multiplier in front and the du on the back end, and let's note that the 1/2 du replaced, substituted, it came off the bench for the x dx. Yes. All right. What else? Limits of integration. All right. We need to remember that we always change the limits of integration as well. That's the difference between these and the ones that we did on example number 1. So, for example, this 0 here, recall, is a value of x. I again will tell you that everything we construct over here is built from the original substitution. So 0 squared, being plugged in for x, is 0 plus 9. So when x is 0, u would equal 9. 9. Notice that lower limit of integration changed. And likewise, the upper limit of integration, the 4, is also a value of x. We plug it in for x. And 4 squared is 16 plus 9, 25. So that new limit of integration, that new upper limit of integration is 25. So we've changed everything. And here's the thing here now. When we change everything over, we're never going to go back to our x. All right? So it's like there's a big old arc here that says, all right, you know what? We're about to jump over and leave our x and run off with u and never come back. All right? So we jump over there and slam that in there, and we've got ourselves a brand new life that we're going to start here. All right? So now it's time to integrate that expression. And so that 1/2 would be in front. This is just the power rule, isn't it? All right? So u to the 1/2 plus 1 would be 3/2. And then recall that division by 3/2 is the same thing as multiplication by 2/3. We don't put a plus C on here. We transfer it over to the symbol we use for evaluate, right? So the integration part has been performed. It's done, yeah. And we replaced it with the evaluate symbol. I would then recommend that we go ahead and simplify this a little bit. I noticed that the 1/2 and the 2/3 could be multiplied out. That's 1/3 u to the 3/2. And again, to be evaluated from 9 to 25. Look at that. We're never going back to our x, are we? Never. We're definite about that. We're never going back. Goodbye, x. Never going to see you again. I'm running off with you and starting a brand new life. All right. And then the evaluate step. That would be where we stick these numbers in as we practiced on a previous assignment. So we would put the 25 in for you. 1/3 times 25 to the 3/2 power. That's the upper limit. Minus, we call that fundamental theorem of calculus, f of b minus f of a, after you take your integral, all right? And then we'll put the 9 in for you. So that would be 1/3 times 9 to the 3/2 power. That would be the lower. And then this is just arithmetic from here, isn't it? So this would be the point where all we got to do is plug those numbers in and crunch them out. And let's go ahead and write this up here a little bit bigger here. So ultimately, this will end up equaling 98 over 98 over, what number is that over after you do all that arithmetic? Well, we line it up, we fake, we jab, we dig, fade away, and it's a 3! It's good! We're the champions! Yes! Integrate, evaluate, celebrate, yes! Rock chalk, here we go! We're the champions, we're number 1! Integrate, evaluate, celebrate, rock on! One shining moment.